Yes, beta. Good evening. A monkey. Auntie is having one or two fever. Okay, don't fight. Work and energy. Just 1 minute, beta. Searching the file. I was searching file, yaar. Monkey, you are asking this many type question means how I am going to. Now you are okay. Hmm. I can't type that time, na beta. I am sending link that time. How I am going to type? Hmm. Good evening, beta. So now we are going to start the class. Get ready for it, beta. So now work and energy class, we are going to understand that. See, you need to first remember one thing. So daily life activity, whatever we are doing, means whatever work we are doing. Wait, I'm sending you one thing. After that, you ask me, and then after that, you tell. Wait, monkey. After that, only I'll start. Now look, beta. We will be. See, WhatsApp. I've sent you something. Now look, beta. That's my condition, bacha. Did you correct paper, ma'am? Which paper, re? All paper corrected already. Score already given. Everything done. Now, are we going to do our work, please? Now listen. So, in our daily life, we talk about the term work, energy, and we need to understand one thing. Yes, class 10 already given. Now, beta, we need to understand that whenever we do some work, understood. So whenever work is done, we need to do some activities. So activities will be letting us know that okay, some work has been done. So like lifting a ball, throwing a ball, kicking a ball, understood, rolling a ball. Ama, afternoon. So only it got delayed, but otherwise I could have started the class earlier. Okay, post in the group class started. Auntie's teaching class. Okay, I'm standing. You see how I'm standing, putting both hand in table and standing. Yes, then also I'm teaching. So now listen, beta. We shall we go our activity, beta? Now understand this. Ki when somebody will be asking you about work and energy, you need to understand that ki whatever energy you are having, based on that only you are doing work. Okay, like morning. Right now, just understand this is the best example for you. I don't have energy because I'm having fever. So definitely, if fever is there, miss work done will become very slow because now I am not shouting. One monkey is telling me anything, I'm not replying to that monkey. So that means what? But all the activities, whatever you are doing, it will be exactly needing some energy, understood? So like playing, skipping, dancing, everything is interrelated. So whenever you will do work, energy will be taken, understood? So energy will be utilized. So from where the energy is exactly coming? The energy is exactly coming from the stored energy that is present inside your body. That energy is exactly letting you do work. Okay, that energy will only help you to do work. That's the most important thing, beta. That's the most important thing. That energy is exactly going to be the most important thing. Got it? So definitely it is very very important to understand. So now in our daily life, we talk about the terms work. Okay, so work will be done when you have energy. Understood? And beta, for energy we need force also. We need force also. So we need, hi Ruchi, we need force also. So see, force means, force can be here considered as external force. Okay, very good beta. So it will be considered as external force. So when somebody, when you want to brush your teeth, actually what you are doing, you are taking the brush inside your mouth. Okay, good evening, Kanish. Now look here, beta. So when somebody will be asking you this question, then what answer you are going to say? So if somebody will be asking you that brush your teeth, so brushing your teeth means what? You are taking brush inside your mouth and brushing is done. No, not possible. So definitely what you are doing, beta, you are exactly giving to and fro motion to brush, so that only the teeth will be exactly cleaned. So here one thing is needed, and that is force, the external force. So when children are playing like Tanish and Sam, they are playing ball. So they are taking one very big ball and they both are throwing ball on each other. So when they are throwing ball on each other, actually what is happening there, they are putting force, and the external force will let the ball move from one place to another place. So that means exactly here three factors are working here: work, energy, and if all this will be exactly because of the application of force. So this is the most important factor. Now we are going to understand in physics, physical language, how we are saying that work is done. Okay, can you tell me one thing? I'm sitting and reading. Did I did any work? I'm sitting and reading. Did I did any work? The answer is no. Now, whatever reading, writing, carrying a bag, pushing a wall, they all will be exactly going to be considered as doing work, beta. But these are all examples of work. Good evening, beta, after so long unlimited video. So definitely I'm fine, thank you. So definitely beta, they will be considered as what? They will be considered as doing work. Okay, they will be considered as doing work. But by physics wise we cannot be able to say that it is work, because work understand one very important thing. Work understand displacement has to be there. Understood? Because work is equal to what? Displacement. Displacement must be there. Understood? So displacement, force into displacement is work done, and for work done, force and displacement has to be there, then only work will be done. When you apply a force, it should have displacement, it should have displacement, then only work is supposed to be done. This is the most simple technology we have to understand. Otherwise you are reading, you are sitting and meditating in one place, that is not considered as work. Okay, it is considered as work because you are spending time with it, but time using and doing some work where you don't have displacement, in physics it is not considered as work done. Okay, so now we need to understand when work is said to be done. Would you now look here? We will be checking some part able to move the wall a little bit, but he asks for his laboring charges. Would you pay him the charge or not? No, definitely we will not be paying him the charge. Live is breaking. Here it is not breaking, beta. Live is not breaking. Okay, life is not breaking, beta. One time check. Now listen. So definitely, beta, would you pay him any money? No. You have given money. You told that you committed for the worker, and you told that now you committed for the worker, and you told that hey, you have to move the wall. But the worker full day tried, but did not able to move the wall. So since the worker is not able to move the wall, according to you, there is no work done. See, the worker applied energy, the worker had used all his internal potential energy, but that potential energy was not enough to move the wall because the inertia of the wall was higher than the force what he has applied there. Understood? What is inertia? We have studied inertia. Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. So that's the state of inertia, beta. So now what will happen? So yes, so answer would be yes, because he has performed his task or work. But in language of physics, he does not did any work. The meaning of work in physics is big difference is there. Actually, in physics, work has a meaning only when displacement is caused. That's what I told you. Ki until and unless the wall will not be moved, until and unless the wall will not change its location, in physics there is no work done, because beta here displacement is zero. So since the displacement is zero, it is exactly not doing any work. Understood? So force application is there. How much? 9 Newton, 10 Newton, 12 Newton, force application is there, but work is not there. So since work is not done, so that means here your displacement is not there, force application is there, but the body is not moving, so definitely it is supposed to have zero work done. That's the most important crucial factor, always remember. Understood? So no work is said to be done by the body. Now small concepts, small things we are going to understand very nicely. Okay, now, suppose Pari gets tired after after 4 hours of study, but Dolly doesn't tire even after 8 hours of study. Who does more work, Pari or Dolly? So definitely, we can't answer it, but we can surely say that Dolly has more capacity of doing work than Pari. The capacity of doing work is defined as energy. Understood? So what is the capacity of doing work? The capacity of doing work is defined as energy. Understood? So the rate of doing work is termed as power. That's also the rate of doing work. So power is equal to work done by time. Power is equal to work done by time. If somebody will ask you, beta, what is power? In simple word, what you can answer? See, physics try to answer in the most simplest way. Don't complicate it. The simple answer is power means what? You told auntie, can you carry 10 kg weight? I said, yes, beta, I'll try. I carry 10. My power is 10 kg weight. Means how much work I have done? I have carried 10 kg weight. For some seconds, I will carry 10 kg weight. So power is equal to work done by time. So beta, what is power here? Power is coming as work done by time. Power is equal to work done by time. Now you said, auntie, can you carry 20 kg weight? Now this time I tried. Literally I tried 20 kg, but I was not able. So definitely I did not did any work, because displacement of the stone is not there. I tried, but I did not moved the stone. So definitely power is not there to carry the stone in respective time. Got it? Simple thing, na? So this is exactly what is called as power. The rate of doing work is considered as power. This is a simple definition. And yes, the rate of doing work is considered as power, and the capacity of doing work is energy. The capacity of doing work is energy. Means how much energy will be there. Based on that energy only I will do the work, Navita. Based on doing that energy, I will do work. So these are two different things, and most important point also. So now let's see concept tree we are going to understand. Now in this concept tree we will be understanding the most important thing. See how these things are getting interrelated. Concept tree, energy. Energy is what? Examples, unit of energy, law of conservation of energy, various forms of energy will be there. Now work and energy intertwined, work done by constant force will be there. And then unit of work will be, we are going to study power, that is unit of power. So these are the things we are going to understand. Okay, so now look here. So now we are going to talk about knowledge based questions. Some knowledge based questions, let's do. Check, a force of 20 Newton is acting on a body of mass 2 kg. What is its acceleration? Come on, go for it. Start. Ruchi, everybody, those who are present right now live, answer the question, beta. A force of 20 Newton is acting on a body of mass 2 kg. What is its acceleration? Come on, tell. So definitely force is equal to mass into acceleration, na beta. What is the simple definition of force? Force is equal to mass into acceleration. Force is 20 Newton, mass is 2 kg, acceleration they are asking. So 20 by 2 is equal to 10. So acceleration will be exactly coming as how much? Force is 20 Newton acting a body of mass 2 kg. Yes, what is its acceleration? Okay, okay. Meter per second square only is coming now. Boss 10 will be coming. Here, typo error is there. It will become 10. Yes, it will become 10 beta. Hmm? Because force is there. Force is equal to mass into acceleration. Acceleration will be coming. So here 10 will be there. Little bit typo error is there. So now velocity of a boy changes from this to this, 3 to 7 in 2 seconds. What is the acceleration acted on the body? So definitely with a velocity changes. So this is initial velocity. U is equal to 3 and V is equal to 7. So acceleration is equal to V minus U by T. So it is 7 minus 3. Time is exactly what? In 2 seconds. So 7 minus 3, 4 by 2. So answer is coming as 2 meter per second square. 2 meter per second square. Yes. Yes, so only. Typo error was there. First check you people are live or not. Answer is A. Absolutely correct. Answer is A. And answer is A. Got it? I'm fine. Thank you, beta. Now look here, a body of mass 20 kg is moving with a velocity of mass given beta velocity given what is the momentum? Momentum is equal to, yes, both the answer, very good. So now next question is body of mass 20 kg is there and velocity is 40 beta. Come on check. Momentum is equal to mass into velocity na. Easy hai, karo isko jaldi se. Mass into velocity 45 and 20 is there. 900 kg per meter. So momentum is equal to what beta? Yes, I'm teaching 10th also. After this only 10th class is there beta. Mass into velocity. Okay beta. So mass into velocity. Mass is exactly coming as 20. Velocity is 45. Now beta if we will mass is kg, velocity is meter per second. So kg meter per second and this part is coming as 009. So sorry, 159 extra I wrote. So 900 kg meter per second. C is the answer. Anybody you got the answer? Yes, option C is going to be the correct answer. Now beta, like this only question, a body of mass 15 kg is moving with a velocity of this and it hits another body of mass this m1 v1 is equal to m1 u1. So this part question will be exactly coming what is the value of v in terms m1 u1 plus m2 u2 conservation is there. So conservation questions will be coming. We will be, I'm sending you this PDF. Yes sir. Huh? Yeah, I'm taking class. Guru, 1 minute. Just 1 minute. I'm thank you, Guru. What are you doing now? Studying in college. I saw Rashmi. Huh? I saw Rashmi. That day came to know. When you completed? Yeah. You just. Okay. So here rate of change. So definitely these. That is not bhai, that is behan. Okay, so these are exactly some things which you need to, so what we are I'm going to do is the rest questions I'm sending you in the group beta. 4 seconds. Okay, the rest questions I'm sending you for solving because definitely these questions in fourth chapter we have finished. So I have just given some extra questions for you for taking some what you call solving it. So try to solve these questions. Now we are going to study work beta. Work in very what you called. I'm going to explain about work. So in our day-to-day life, the word work No problem, beta. Today class is recorded. Usually classes are not getting recorded now, so it will be okay. No problem. So you can see the class from the beginning part also, beta. Not at all at issue. You can see the class from the beginning section. It is not at all going to be an issue. Okay. So now we are going to start this part. So if somebody will be asking you about work, okay. So day to day life, the word work means kind of mental and physical activity. Work is not only physical activity, work is mental activity also. Like reading is also considered as work, okay. Now solving a puzzle is also considered as work. So when we are thinking, that is also work. So when you are saying, somebody will say you, hey, what you are doing, wait, I'm thinking. Thinking is also work. I'm sleeping is also work. So taking rest is also a type of work. Cooking is also a type of work. So definitely whatever activities you are doing, it is considered as a part of your life, and it is considered as work, because it is utilizing energy that is possessed inside the body after you are taking food. So these are some things which is very very important. Okay, so now look here. So now in physics, work is done in when force is applied on and displacement has to be done. But beta, as we are knowing that in the beginning part of the chapter itself, I told you whatever activities you are doing, that is not supposed to be called as work according to physics. Physics says that ki I will consider work only when it will show displacement. Understood? So physics, yes beta, it is exactly talking about displacement. So when it will be talking about displacement, work is supposed to be done. Okay, the body must be displaced from one position to another. Work is said to be done by force on the body. If the force applied causes displacement in the body, definitely beta. So now example we are going to understand. So in the example section, let's check this one out. So when somebody will be discussing when a box is pushed on a floor by applying a force. Now let's talk about this. So when box is pushed on a floor by applying force and it moves through some distance, work is said to be done. In this case, the applied force displaces the box. Definitely, beta. So we are going to understand this section like okay, this is exactly the floor, and in this floor, one box is kept. Okay, now once the box is kept beta, when you are applying force, the box is moving from its location. Understood? So the box is getting displaced. So in this part, distance work is said to be done. So force, and it moves through some distance, and it is said to have work beta. So it is doing work because it is getting displaced. Understood? Because external force you have applied. In this case, the applied force displaces the box. So work is a what quantity beta? Always remember, work is a scalar quantity. Till now only two things we studied. This much we have talked, but only two things we have studied. Work is a scalar quantity. Understood? And work will be done only when there is a displacement. Got it? So it is directly proportional. And third is work is directly proportional to force applied. Means the direction where the force will be. If work will be more, if force will be more. Understood? So work is directly proportional to force. Work is directly proportional to displacement. Okay. Now we are going to understand this one. So if somebody will be asking you about force and displacement, how work will be directly. So work will be directly proportional to force beta. So how much, and then work is also directly proportional to displacement traveled. Okay, in the direction of displacement. So if I push a ball like this, if I push a wall like this, if I push a book or human, anyone, so the direction where I'm pushing, the object will be sliding that direction only. So definitely, yes, so work done is definitely a scalar quantity. Next important point is कि work will be done when there will be displacement. Understood? And force application will be there. So there are certain factors which need to be discussed here. So simple things we have understood. We are not making it very complex. In the most simplest way, we try to understand about work beta. So I hope till here you have understood. So work is a scalar quantity or a vector quantity. What is the answer? Work is a scalar quantity. Work is directly proportional to force. Work is directly proportional to displacement. These two things are there. Done. Okay. Now we are going to talk about constant force, work done by constant force. Now beta, one question I'm going to ask from you. Just say, can displacement be possible without force? Can displacement be possible without force? Just one simple question I have asked. Can displacement can displacement be possible without force? If somebody will be asking you this question. Very good. So people are exactly divided into two groups. Super. So definitely you need to first brush up the concept, understand one more time, think one more time, and then give the answer. Can displacement be possible without force? Give me a very, very applicable reason behind it. Applicable reason behind it. Say. Anyone? Beta, this is possible. How can it not be possible? First understand, come out of physics. Because first, whenever you will be thinking, you will be only thinking precise. Precise is given force I will apply, then only the work will go. What if the body is already in motion? The body is already in motion. See, earth is exactly right now in, earth is having momentum, it is moving, and its inertia is not getting disturbed. Understood? So earth is not needing any external force, but yet it is having displacement. Think very nicely. Think very nicely. So if the object is already in motion, yes, if force is already in motion, no, object is already in motion. So if the object is already in motion, then are we going to apply force? No. If the object is already in motion, it is not needing any external force. It is exactly in having some momentum. That momentum will not get disturbed. So definitely it will have displacement without force. So when our object is already in motion means we don't need to push any force, apply any force on this. So this is what. So already in motion means it will continue its state of motion. Understood? Like right now the earth rotates around sun. So when it is rotating around sun, definitely it is having its own inertia, own momentum, which is not getting disturbed. So definitely it does not need any external force. But beta, if you apply any external force, then earth direction may change. Got it? So that's very important thing. Okay. And second important point is zero net force also will be there. Na? Zero net force will also be there. So that's many important things are there. Understood? So already it is having velocity means it does not need any external force. Yes, yes, absolutely. But reverse is displacement is not possible without force. Correct? Ah? Displacement cannot occur without force. So when work done is possible without force, yes, work done is without force because the body is already having momentum. But if displacement I'm going to correlate, displacement need force. Understood? So because to start anything, so but if I want to start anything, I need force. If I want to start anything, I need force. So definitely there are certain factors. I'm reading all your comments. Thank you so much. So definitely you need to be very, very accurate and very, very, see, you can't be like this. Physics means you 1, 2 lines are written in book and you just mugged it out and write means definitely knowledge will be to that level only. So you need to be come out of your comfortable zone and then you need to study the best. Got it? So don't study like that. It is going to be problem for you. So work done is equal to force into displacement. What is the unit of force? The unit of force is Newton beta. What is the unit of displacement? Meter. So Newton meter, that is 1 joule is equal to 1 Newton into 1 meter. So if somebody will be asking you, joule will be what? Newton into meter. So 1 joule. So if somebody will be asking you what is the definition of 1 joule, world is not like that right now that they will be asking you that what is 1 joule. Now they will be asking that is work done possible without force. Understood? Is work done possible without force? Is displacement dependent on force or not? So they will ask questions like this. Don't think that they will ask this question, this simple question. They will ask to define 1 joule. Everybody, children are also knowing that work done is equal to force into displacement. So what is 1 joule? 1 joule is 1 Newton of force applied on a body so that it will have a displacement of 1 meter. That's it. Definition. We can speak definition on our own, but the most important thing is when, what, how, and practical leading to the content is also very, very important. So 1 joule is equal to 10 to the power 7 dyne beta. Okay. So 1 joule is equal to 10 to the power 7 dyne into 2. If you will do, it will become erg. Understood? So these are some definitions. These are some formulas which we need to definitely understand. Now we are going to go to the next section of it. I hope you might have understood this part. So we see that work done is equal to product of magnitude applied, that is magnitude of applied force and distance. So that's what is force. Now we are going to understand what questions I have asked. Based on that questions, we are going to understand the things better. Now, if force is equal to 0, then work done will be 0. That's it. Understood? So, if force is equal to 0, then work done will be equal to what? Work done will also coming as 0. Huh? But it is also one thing was there that I have discussed. So some of the preliminary things you need to understand nicely. So example, a student revising his notes by memory without moving his limbs is doing no physical work. So a meditating saint is doing no physical work. Does he keep sitting for hours? Understood or not? So he is exactly, he keeps sitting for hours also, but there is no here. So force application is not to be seen anywhere. Understood? So now if displacement is 0, then work done is again going to be 0. So a foolish labor trying to displace a building has done no work through, though he may spend the whole day. So erg joule, these are exactly some of the conditions I have discussed right now. Okay. Now erg and joule are the absolute unit of work done. You need to remember. Understood? Work, erg and joule. And I have discussed about erg. One joule is equal to 10 to the power 7 erg, and 1 joule is equal to 10 to the power, sorry, 1 joule is equal to 10 to the power 7 dyne. 7 into 2, it will become erg beta. One time I'll check these values. I think here 1 joule is equal to 10 to the power 7 erg. Now we will be going with some of the questions. Let's talk about it. A force of 10 Newton act on an object. Come on, go for it. Try this question because already it is solved. Solve this question, beta. So 1 joule is equal to 10 to the power 7 erg, you remember, and now solve this question. Here question is there, na beta, little bit it is not having time. See here, a force of 10 Newton act on an object. Force is given as how much beta? 10 Newton. Okay. The displacement is 4 meter. So what is the displacement here beta? The displacement is 4 meter. Huh? So force is 10 Newton, displacement is 4 meter. Now, what is the work done? So, we know that work done is equal to 10 into 4 joule, that is 40 joule. This is the putty question we had to ask. So, definitely 10 into 4, 40 Newton, that is Newton meter. So, Newton meter is considered as what beta? Newton meter is considered as joule. So, it is coming as this much value. I hope till here it is done beta. Now, type of work. Now, work is a scalar quantity. Now, how many type of work will be there? Absolutely correct, children. So, how many type of work will be there? Till here, whatever I taught you, was that very difficult to understand or easy to understand? Can you tell me? Was it very difficult to understand or easy to understand? Come on, say quickly. Yes, because we did not made it difficult to listen. We made it very easy. We had discussed about it in a very simple tone, not at all in a very conservative way. Now we are going to discuss some of the most important thing. Work is of three types. Understood? Positive, negative, and zero work done. So we need to understand that when the applied force, now beta in simple technique we are going to understand. See, force and displacement. I pushed you and you went forward, work done is positive. Simple. I pushed, this is there, I pushed it, it went forward, force is. So when you applied force and displacement is in the direction of force, understood? Artistic world high. So when we are going to talk about this, so work done can be positive, work done can be negative, and work done can be zero. So beta positive work done, how can we be discussing about positive work done? Sorry. So work done is said to be positive if applied force is in the direction of displacement. Understood? Simple technique beta. What is the simple technique here is, so this is exactly the weight you applied force in this direction, displacement is in the same direction. Then work done is supposed to be positive. That's it. Don't think too much. So here work done is supposed to be. So work is having displacement, force is having displacement. In the direction of displacement is exactly there. So it is force into displacement, and here work done is positive. Now example, gravity if a body falls towards the earth. So beta, what and all examples we can take? Like key first the kuti example we can take, whatever we are throwing, the gravity is pushing it, taking it towards itself. That's a positive work done. So if the object is returning back, then it is considered to be as positive work done. So returning back of object from anywhere, if you are throwing, it is considered as positive work done. It is considered as positive work done. Now work done by a horse pulling a cart. Definitely horse is pulling the cart in the direction where it is pulling, the object is moving. That is also positive work done. Okay, work done by stretching the force acting on a spring. Yes, spring we will tie and allow the spring to go down. So work is done down of the string. So definitely it is also going to be a positive work done. So three cases of positive work done we have taken. Okay, now we are going to talk about negative work done beta. I tried to take you towards my direction, you are going in opposite direction. Okay, I try to take you towards my direction, you are going in an opposite direction. So here what is done? You are going opposite of my work, so work done will be considered as negative. Okay, now here said to be negative if applied force is in the direction opposite to displacement. Okay, like braking force, whenever you applied brake. So if I'm applying brake beta, what will happen? Brake application means what? It will exactly distort the force. So work done will be, friction is also opposing force, brake application is also opposing force, that comes under retardation. Okay, so work done by force of gravity when the body is projected away from the surface of earth. So when I will throw like this, the object will go up, it is negative work done. The object is going down, it is positive work done. Negative work done, positive work done. Negative work done, positive work done. Understood? Friction, negative work done. Hmm? Applying brake to stop the vehicle, negative work done. Accelerating, positive work done. So if you are accelerating your vehicle, positive work done. If you are putting brake, that is negative work done. Understood? Floor, water is more, friction is less, negative work done. No, positive work done. Because if friction is more, trying to stop, definitely work done by friction is negative, because it will stop the motion. Understood? So definitely these were examples of positive and negative work done. Zero work done, already we have discussed many things about zero work done, but now beta we are going to understand work done when one factor or both the factors will be zero, or force is 90-degree with the displacement. That's again one simple thing we are going to understand. Okay, so work done, zero work done. Work done is said to be zero if the applied force is zero, or displacement is zero, or angle between force and displacement is 90-degree. This is what force displacement. So if force application is here, displacement is here, force displacement. So definitely angle subtended between force and displacement, if it is coming 90-degree, then also it is coming, ma'am. Shams. Ma. Just 2 minutes, ma'am. I'm coming. Yeah, yeah, he came. Ma'am. Yes, yes. but that need to be cleaned little bit. Box was empty for some time. Just give me 2 minutes, I'm coming, ma'am. After that, you tell them to bring it up, ma'am. You tell them to bring it up. After that, open it, I'm coming, ma'am. So here we need to understand beta. So work done by the tension in the string of a simple pendulum, that is 0. Work done by centripetal force, work done by pulley carrying load on his head, definitely all these examples of 0 work done, because force is perpendicular to displacement. Whenever force will be perpendicular to displacement, it will be considered as 0 work done. Now beta, one question will be there, भाई simple pendulum में work done 0 कैसे हो गया? Simple pendulum में work done कैसे 0? This is the pendulum beta. Definitely the pendulum oscillate like this, tangential motion flow will be there, so definitely it will go perpendicular to it. So only, so work done by tension in the string in a simple pendulum is 0 work done. Work done by centripetal force always. So centripetal, centrifugal, centripetal. So one, this will be exactly there. So this tangential force will be there, that work done will be exactly 0. So many things are there, we need to check. Fine. Work done by pulley carrying load on head, that is also perpendicular, so definitely work done will become 0. Okay, so I'm just keeping it till here beta, because little bit health is not good, some small time gap I am teaching. So tomorrow next class work done I'm going to teach. Definitely this content is very important. I'm going to explain it nicely. Yes, I'm going to explain it nicely, and these sections we will be understanding with diagrams. I'll be talking about angles beta, because angles are very important, and angular content need to be discussed nicely. So this part we are going to discuss. Now I think today itself we will discuss angle 90 degree, 0 degree, cos theta. So now look here, beta. One thing is there. Don't go, Aru. Wait, I'll discuss this part. So we know that it is a dot product beta. Work done is force into displacement, dot product is there. So whenever you will consider that angle subtended. So when the body movement is there, the angle will come between 0 to 90 degree. Cos theta is coming as positive, because yes, cos theta will be like Fs cos theta. Sorry, Fs cos theta, that is work done beta. Okay, now beta, this theta part comes between 0 to 90 degree. If it is 0 to 90 degree, cos theta will be coming as positive. That means work done is coming as positive. Now when theta will become 90 degree, cos 90 degree value is 0. So work done will become 0. So only beta, when we are talking that given this is exactly force and this is force application and this is displacement. So they are subtending what degree? 90 degree with each other. Force and displacement subtending how much degree between each other? 90 degree. So work done will become 0. And when it will be more than 90 and less than 180 degree, then cos theta will become negative. So work done will become negative. Why? Because if somebody will write work done definition, then work done is dot product of force into displacement. So it will become Fs cos theta. Fs cos theta. Dot product between force and displacement will come as Fs cos theta, where force magnitude, displacement magnitude, and cos theta will be coming. Angle between force and displacement. Okay. So this is something one more time we are going to study in next class, beta. Bye for now. Tomorrow math, surface area and volume we will be. It will be very interesting session, beta. Bye bye.